Hello everyone and welcome to part 5 of the Breakout game tutorial. Today we will talk about collision detection and I will show you how we can implement it in a simple example. I have here a minimized B4X game template project. So what I have is four type objects: size, point, brick and the ball. I have a B4X canvas, some variables. So as you can see, we are not doing anything special right now. We have here just the functions to create the type objects. We are initializing the canvas and basically that's it. We'll need a timer, so let's create a timer. We will also need to create a ball object, so let's create it. And we will also need a list to hold all our bricks. So let's create a list and call it brick list. So basically that's it. Now we can initialize our list and we can initialize our timer. Let's give it an event name as timer and set the interval to 1000 divided by 60 frames, and let's enable the timer. Now we will need to create a ball, so let's create the function for that, and also we need to create the bricks. We will pass a position for the ball and also for the brick, and we will create more than one brick, so we'll also pass an index. So let's create the position, create point, viewport divided by 2, and the viewport height multiplied by 0.8. And here we can create 6 or 7 bricks. So let's do it in a loop. We'll also need first to create where the bricks should start, in what X position. And here we can create the point object. And the Y position, and the index will be the I value. So here we are creating our ball. Okay, we are calling basically the function to create a ball. We have not added any code to the event, but we are calling the function and we are passing a position, a point object. And here we are doing the same also for the bricks. So let's create our ball. the position will be the past position object. We will set the radius value of the ball, and we'll set the speed on the x-axis and the speed on the y-axis. This is the speed that will move the ball. Okay, let's do it. So now we have set the x speed to 3 and the y speed also to 3. That means that the ball will move in this direction, like this. Okay, it will go to the right and to the up. And now we can create the bricks. Let's set the index value. Let's set the size. Let's also set a random color. Let's set the isHit value to false. And let's add the brick to our brick list. So we are creating our ball here and we are creating all bricks. Then we start our timer. So we need the timer event, the timer tick event. And inside we'll add some functions. So first we will clear our canvas. Then we will move our ball. We'll check the collision with walls. Check collision with bricks. Draw the ball. Draw the bricks. Draw status. And invalidate the canvas. Let's add all events. So every tick we will call all functions here And this is the right order to do it. So first we'll clear the canvas, then we'll move the ball. After we're moving the ball, we'll check the collision with the walls if the ball hits one of the 4 walls, and then we check if the ball hits any brick in our canvas. Then we'll draw the ball, then we'll draw the bricks, we'll draw the status if all bricks are hit, then we'll draw you won on the screen, and we'll invalidate the canvas. So here we can clear the canvas first. Let's move the ball. So just ball position X will be ball position X plus ball speed X, and also for the y-axis. Now let's draw our ball. Let's draw all bricks. We can do it in a loop. Now we'll say that if the brick list size is 0, we'll draw on the screen that the player has won the game. And let's invalidate the canvas. So basically we have done everything. All we need now to do is the collision detection. So I just want to say that this is not a game. What we are doing here, we are only creating a ball that will move around the canvas, and if there is a collision it will change its direction. So we will not have any control of the ball, or we will not have a pedal inside, just the ball will move around the canvas, and if a brick is hit it will disappear. So first we need to check if the ball hits a wall, so we can do something like this. So if this is our canvas, and this is our ball, we are just checking if the x position of the ball minus the radius is smaller than our left wall position, that is 0. If it's true, then we'll change the x speed like this. If the ball is moving like this and the ball position minus the radius is smaller than the left wall position, that is 0, then the ball x speed will change and the ball will start going to the opposite direction. And the same here, if the ball position, x position, plus the radius of the ball is bigger than our canvas size, then it will change direction and go back. So we'll say if ball position x plus ball radius is bigger than BPW, so first we check the right wall side, then the ball speed will be ball speed x multiplied by -1. So it will be the opposite of the current speed value. So if it's 3 multiplied by -1 will be -3. If it's -3 multiplied by -1 will be 3. So it will always change to the opposite. So this is for the right side of the canvas. If ball position x minus the ball radius is smaller than 0, then we will also call this function here. So we will again change the speed of the x-axis. So if it's smaller than 0 or if it's bigger than the canvas size. I want also to update the ball position. Position x is the weight of the canvas minus ball radius, and if it's smaller I will update the ball position to be the ball position on the x value to be ball radius. So what I'm doing here is basically this. We are moving the ball on each tick, on each timer tick, 3 pixels. Okay, so let's say the ball was on a value, on the x value 1. So on the next tick it will be on -2. Okay, it will be somewhere here. So what I'm doing here, I immediately update the position, and I also change the speed value. So I will not leave it here and from here start moving, because on the next tick event it will also say that it is smaller than the value, and it will keep here moving up and down and not going back. And the same we are doing also on the right position, and this will prevent a scenario where the ball is stuck on the side and moving only up and down. Now on the y axis we can do the same. So actually we can run now the program without creating the bricks and see what we have. The reason that we have here U1 is because the brick list is the brick list size is 0, but as you can see the ball is moving, and every time it hits a wall it will go to the opposite direction. Now if we are creating the bricks and we run the project, the collision on the bricks is not detected because we have not set it. So this is the only thing that is left, and let's do it right now. I will show you an example in a painting. So let's say we have here our ball. First, there are many ways to check collision between two objects. For example, we have a circle to circle collision detection. So let's say we have another circle, and let's say it's maybe even bigger than the current than the other circle. Let's say something like this. So what we can do is always check the distance between both, and if the distance is smaller than both radius, for example the radius of this circle is 3 and the radius of this circle is 6, so if the distance is smaller than 9, then it means both circles are colliding. For example, if we have something like this, the distance will be in this case smaller than both radius. Okay, and we know that there is a collision between both. So this is how we can check collision between two circles, and if we are doing it with a circle and a rect, then we are doing it almost the same. So what we are checking is always the distance between the center of the ball and the frame of our rectangle, and if it is smaller than the radius, it means that the ball is hitting somewhere in our rect. So we are just checking the distance to our frame of the rect, to the border of the rect. I have here the function for that. I will copy and explain it. I will copy and paste it here. So this is the function, and here what I will do is going in a loop through all bricks and check for a collision. First, let's set a index value, because we are using the for each loop, and for that we will need to know the index value. So let's say for each b as brick in brick list, if is colliding b position and b size, then we'll change the is hit value to true, and we will remove the brick from the brick list. And we'll exit the loop, else we'll increase the index value. Actually, updating the is hit value here inside will not affect anything, because we are immediately removing the brick object. But for example, if you want to create an explosion animation or something like this, then you can leave the brick inside the brick list, don't remove it here, and then you check in another event if the brick is hit value is true, then you draw the animation in that position, and then you can remove the brick. But actually now there is no need to update the is hit value, but I will keep it like this because it can be used in another scenario. So let's check now what we have. So as you can see, the ball is hitting the bricks and they disappear, so it looks like everything is working fine. And as soon as all bricks are hit, we should see U1 text in the middle. Yes, this is also working. So here is basically where you would end the game and go the next level, or I don't know, we can do maybe animations or whatever you want. So basically now we have a simple example on how we can make a collision detection, and now I will also explain a little bit about the function, so what we are doing inside. So what we are doing is, first we set two variables, side x and side y, to the ball x position and to the ball y position. And now we are checking where the ball is according to the brick position. So if the ball x position, that is the center of the ball, is smaller than the brick x position, then we'll set the side x value, we'll update it to the brick x position. And if the ball x position is bigger than the brick x position plus the brick weight, then we'll update the side x position to the brick x position plus y. So we'll set it here, okay, on the right side of the brick. Else, if the ball x position is between the brick x position and the brick weight, then it will stay as we've set in the start. So it will stay to the ball position x. And the same we are doing also on the y value. And after that, what we are doing is just we are setting a new two new variables, distance x and distance y, and here we'll just calculate the ball x position minus the side x. So if the ball was on the x value, it was between the brick left, the brick x value and the brick weight, then it would stay as the ball x position, and that means that the distance x will be ball position x minus ball position x, and that will be 0. Else, if it was here or here, then we'll have a value here that is bigger than 0 or smaller than 0, but it won't be 0 because there must be a certain of distance if the ball is not inside the brick on the x value. And the same we'll do also on the y value, and then we just calculate the distance with this simple formula. And if the distance is smaller than the ball radius, we know we have a hit. So the ball is hitting the brick. So it means if the ball is somewhere here, the x value of the ball is smaller than the x value of the brick. So we'll set the side x to the brick x value. The y position of the ball is not lower and not higher. That means it will stay to the ball position y. That means that distance y will be 0, but distance x will be smaller than the radius of the ball, as we can see here. And then with this function we'll return a number that will be smaller than the ball radius, and that means that the ball is hitting our brick, and it doesn't matter where it hits, it will always return the distance smaller than the ball radius. And this is basically a simple function to calculate collision, to calculate the distance between a circle and a rect, and return if the circle is colliding with the rect. Normally I would use Box2D for that, because Box2D is a very precise library that will help you a lot in collision detection. So I would also recommend you to have a look at this site of Jeffrey Thompson. He's explaining here much better than I do about collision. You have here point to point. You have also the code for it. You have explanation and also the code. So this is basically what we have. You can see that he is doing the same with calculating also the distance. Is the same function that we have. So have a look at this site, and thank you for watching. I will include the source code in B4X.com, so you are welcome to go to B4X.com and download it. So thank you for watching, and see you on the next tutorials.